Given m and n, where k is a constant, and asked to determine the simplest form of the matrix Mn. We've got to do quite a lot of work here, but then we get follow-through marks quite easily later on. So we're going to create a 3 by 3 matrix. So I'm going to do this row by this column. That will give me 2k minus 14 plus 2 minus 12. I thought I'd just do it away from the main bit so I can just write the result in. So 2k minus 24. Then for the second one, it will be 12 minus 20 plus 8. We get 0. And then minus 20 plus 24 minus 4 is also 0. Next one, k squared minus 7k plus 4 plus 6 gives k squared minus 7k plus 10. And then 6k minus 40 minus 4, so 6k minus 44. And then minus 10k plus 48 plus 2, which gives minus 10k plus 50. Finally, let's deal with the last row. So I'm going to get 4k minus 28. Deal with this one. Plus 2 plus 6 gives 4k minus 20. Then 24 minus 20 minus 4 gives 0. And minus 40 plus 24 plus 2 gives minus 14. And this is our matrix Mn. Then told in part B, given that k is 5, to write down Mn. So I just replace all my k's by 5. I'm going to get 10 minus 24, which is minus 14. K squared minus 7k plus 10, that becomes 25 plus 10, 35. Minus 35, I get 0. And 4 times 5 minus 20 is also 0. We keep our zeros here. 30 minus 44 also becomes minus 14. Then 0. This becomes 0, and this becomes minus 14. So there we go, we get this diagonal matrix. And we're asked to then hence write down the inverse of m. We don't need to do the determinant or anything here. We actually have the result, really. We've just shown that mn is equal to minus 14i. And that means that m times minus 1 over 14n is equal to I. And that means that the inverse of m is minus 1 over 14n, because the two multiplied together give the identity matrix. So I just need to put 5 in here, so I get minus 2. And then I can write my matrix down. Now I'm going to write it as minus 1 over 14. I don't need to multiply every single element. And then I just need to write that matrix. Minus 2, 6, minus 10, 2, minus 20, 24, minus 3, 2, and minus 1. Finally, we're asked to solve these simultaneous equations, and it doesn't say hence or anything, but it's implying it. We've got 2, 1, 4, 5, 2, minus 2, 4, 1, minus 2 as a matrix that we're timesing by x, y, z, and that is equal to 2, 3, minus 1. And if you place k by 5 up here, they're exactly the same. Okay, so this matrix is equal to M. And therefore, x, y, z is going to be the inverse matrix multiplied by 2, 3, minus 1, which is minus 1 over 14. I'm just using my result from up here now. Times by this matrix. Sorry, I'm running out of space to fit it in. And you've got two options. You can either do this by hand, just like before, really, or you could even put it in your calculator. But I'll tell you what it should give you, minus 1 over 14, because, just multiply the matrices together and then times by minus 1 over 14 times 24 minus 80, 1. And that means that x is equal to minus 24 over 14, which becomes minus 12 over 7. Y is then 40 over 7. And z is minus 1 over 14. And there we are. Okay, so nice question on inverses. Hope you enjoyed it.